important concept in mathematics. We always used to study log 1 equal to 0, but we don't know why. Log 1 equal to 0. Because we used to memorize some values in our life, and this is one such value, that is log 1 equal to 0. Not only this log will be called as common log. Also natural log of 1 is also equal to 0. Natural log of 1. So what is the difference between this and this? Okay. See, there are two terms in logarithm. One is common log and another one is natural log. In common log, we will have base s 10. In natural log, we will have base s e. Okay, base s e. So this can be written as log 1 to the base 10, and here we will have log 1 to the base e. In both the case, we are going to have the same result equal to 0. So this can be simply written as log 1. It is not necessary to mention this 10 in the base since it is common. Okay, log 1 to the base 10 can be written as log 1 simply, but it can be written as natural log of 1 equal to 0. So now we are going to see why this result. So before going to the result, we want to know the fundamental thing in logarithm. Fundamentally, we will have logarithm of m to the base a equal to n. Means this form is called logarithmic form. I shall write here logarithmic form will give you the equivalent exponential form, or it is equivalent to the exponential form a power n equal to m. See here, before going to explain further, I want to clear one greatest misconception among students. The students always used to think exponential means it is e. The students always used to think exponential function means it is always e power something. It may be x or x, it may be x, okay, or y, whatever the variable is. Okay, but always the students used to think like this. It is wrong. Not only e power x. Whenever you are having a variable in the power of any constant, then the function will be called as exponential function. Okay, this function will be called as exponential function, because what is exponent means this x is exponent, and this a is base. Here also in the same way, this x is exponent, this e is base. So not only e power x is exponential function, a power x is also exponential function, even 2 power x is also exponential function. Okay, now again we are coming here. See, if I am having a log m to the base a equal to n, then its equivalent exponential form can be written as a power n equal to m. That is, the base remains the same, Okay, even in the logarithmic form or in the exponential form, the base will always be the base. But the result of the exponential form will become the result of the logarithmic form will become the exponent of the exponential form and give you the result what is the main variable in the logarithm. In the same way, the result of the exponential function will become the main variable for which we are going to find the logarithmic value in the logarithmic form, and the exponent in the exponential form will become your result in the logarithmic form. Okay, so we are going to keep these ideas in our mind and going to proceed further. So if I'm taking this exponential form a power n equal to m, I will have the equivalent logarithmic form as log m to the base a equal to n. This a should be our base. So our base should be either 10 or e, not anything else for our result. Okay, for our result. We had already discussed log 8 to the base 2 in some other video. That is log of constant with some other constant, not 10 or e. If you are having this means, so for example, if you want to have log 8 to the base 2 means you have to find the logarithmic value of these two and you have to divide them, then only you will get log 8 to the base 2. So I am not going to discuss about some different base. I am going to consider only these two terms as the base. These two are constant. E is also constant, and we have to know that the value of e power 0 equal to 1 comes from the formula. Also e power 1 equal to is approximately equal to 2.71828. It will goes on like that from the formula 1 plus x by 1 factorial plus x square by 2 factorial plus etc. So from this formula only we are having all these values. Okay, so now my a is either 10 or e, either 10 or e. So if I want to get this 10 power something to become 1 and this e power something equal to 1. Okay, 10 power something to be 1 and e power something to be 1 means definitely you know that this 10 should have the exponent as 0 and this e should have the exponent as 0 to get 1 as the result. Because anything power 0 equal to 1. Now if this 0 is in my exponent, that is for n, what will become my result? In logarithmic form, 0 is going to be my result, and I am going to have log, what is the base here? Base is 10, the base will never change, and what is the result here? In the exponent form, it is going to be your main value for which you are going to find logarithmic value. So here you will have log e to the base 1 equal to 0. This base will give you this result. In the same way here also, this value give you this result when the base is this. Okay, so now we have shown that log 1 equal to 0 or natural log of 1 or natural log of 1 equal to 0 by using the fundamental result of logarithm. But it is it is very important for me to explain it in a more simple way also. See, keeping the fundamental things in mind and to getting this result is one way, but what is the simplest way to keep the value unforgettable in mind means it can be also established by using two formulas. I am going to take two formulas. Log m by n equal to log m minus log n. All of us know this formula. The second formula I am going to take is log m power n equal to n log m. So here the base may be either 10 or e. We are not going to mind that for any base. Any base means for it may be 10 or exponential form I am going to speak. Okay. Now what will happen if I am taking n equal to m, and here what will happen if I take n equal to 0. Before that, why I am taking n equal to m and why I am taking n equal to 0? Because I am going to write this one as the division of same quantities. This one can be the quotient when I divide the quantity by the same quantity. Okay, the division of same quantity will give you the quotient 1. And why I am taking here n equal to 0 means we know that anything power 0 equal to 1. So here we are having m power n. Okay, here we are having m power n. So if I want to have 1 means I have to make this n equal to 0. In the same way, if I want to have 1 here means I want to divide this m by m. That is why I am taking n equal to m. So now you can see the left hand side will become 1 easily and right hand side will become log m minus log m. We don't know the value of log m, but we know that fundamentally the subtraction of same quantity will lead you to 0, will give you the result 0. So here log 1 equal to 0, log 1 equal to 0. If it is base 10 you will have log 1, if it is base e you will have natural log 1 equal to 0. Okay, now here I am going to write this m become 1, log m power 0 will become 0 log m. This log m power 0 is log 1 equal to 0 log m. So 0 into log m. We don't know the value of log m, but we know that fundamentally any value multiplied by this 0 will give you the result 0. So log 1 equal to 0 if the base is 10. Natural log of 1 equal to 0 if I am having base e. Okay, so in this video I have explained you why the value of log 1 equal to 0 in 3 ways. One is by using the fundamental result of logarithm, that is if we are having an exponential form, what will be its equivalent logarithmic form. From that we have taken the result and we have proved that result log 0 equal to 1. The next 2 ways are using the formulas log m by n and log m power n. Okay, I hope you have enjoyed this video and I am very sure this video will be very useful for the basic learners in logarithmic. Okay, so thank you all for watching this video. We will catch you in some other beautiful videos related to mathematics. Thank you all for watching this video once again. Thank you.